And now that our partitioning is complete, it's time to see how we can use our disk space. As mentioned earlier, Unix-like systems can treat disks and disk partitions as files. And some databases, for example, can use raw disk partitions to store data with a higher performance. But most of the time, disk space is used in the file systems. Unix-like systems, and especially Linux, support many different file systems. All the details of their implementations are reduced to a common denominator, the virtual file system abstraction. One of the first virtual file system mechanisms on Unix-like systems was introduced by Sun Microsystem in 1985. It allowed Unix system calls to access local UFS file systems and remote NFS file systems transparently. For this reason, Unix vendors who licensed the NFS code from Sun often copied the design of Sun's VFS. Once the file system has been created, we can mount it in a single directory tree. Navigate through the hierarchy, read, write, work with owners and permissions according to the restrictions imposed by the file system's internals. The standard tool for creating a new file system is MKFS. So we can choose some file system parameters and type of file system to create. But it's actually just a wrapper around the real MKFS tools for different types of file systems. And they all support their own set of options. The most commonly used file systems in Linux right now are ext4 is the Linux journaling file system or the fourth extended file system, which is the successor to the extended file system line originally created in 1992 by Rémi Cart to overcome certain limitations of the Minix file system. The ext4 file system can support files up to 16 terabytes and volumes with sizes up to 1 exabyte. but this may be limited for certain system versions. For example, for RHEL 7 and 8, it's 50 terabytes. And XFS is a high-performance 64-bit journaling file system created by Silicon Graphics in 1993 for their Unix called IRIX. Although XFS scales to exabytes, the host operating system limits can reduce this limit. For example, 500 terabytes for the maximum file size and file system size for RHEL 7, and 1 petabyte and 8 exabyte for RHEL 8. Typically, X4 provides better performance for small file systems and machines with limited input-output capabilities, while XFS provides better performance for large file systems on machines with high-performance parallel input-output. Also, in XFS, it is more difficult to reduce the size of the file system. With the MKFS options, you can set various parameters for creating the file system. For example, optimize it for storing large files or for more smaller files. Once the file system is created, we can mount it. In most cases, this happens automatically when you insert a flash drive or SD card into your computer, but in some cases it needs to be done manually, and you can do it by running the mount command. You just need to specify device and directory mount point, and after mounting you will see the contents of the file system from this device or pseudo device on this directory. And also you can choose the mount options. For example, we can mount the ISO image with the loop option. And then we can unmount it. So we can unmount file system by the command umount with the device or directory as an argument. But Linux, Unix will not allow you to unmount a device that is busy. There are many reasons for this, such as a program accessing a partition or open file, but the most important one is to prevent the data loss. You can use the fuser and And LSOF commands to find the processes that are locking your file system. The KQ option of fuser can help you with this. Finally, we can check our file system. For journaled file systems, recovering from a power outage is not as relevant, but in some cases it may be useful. In a difficult situation such as a damaged hard disk during system boot, you may receive an error message recommending that you run the fsck command. File system check to check the file system. As we can see, we have many options for the fsck command, but the main one is why. Yes, this means always try to fix any file system corruption which you find automatically. Otherwise, you could get a zillion troubleshooting questions during the fix-up. After completing the repair, you can find some lost data in a special directory, lost plus found, in the root of the damaged file system, which consists of many directories and files whose names contains only numbers. Inode. About inodes, see our Under the Hood lecture about links and file system internals. And then you can rename them manually. For example, you found some directory with the files. PSWD, group, and shadow. This means that this is etc. Or sh, ls, and cp. This means bin, and so on. And finally, a few words about swapping. Swapping or paging is a memory management scam by which a computer stores and retrieves data from secondary storage for use in main memory. It is an memory management unit-driven virtual memory mechanism that is used in modern operating systems to use secondary storage in order for programs to exceed the amount of available physical memory. For more information, look at Under the Hood virtual memory lecture. So, this means you can run applications with a total memory usage that exceeds the physical RAM on your system. The scheduler sends inactive process to disk swap and loads active tasks from disks into memory. This can reduce overall system performance, but increase the ability to run applications. So the main program for creating for creating of swapping area is mk swap. You just need to specify the device as an argument or a file if you need some temporary swap space, like Microsoft does on Windows. Then you can enable swap space with the command swap on. After that, you will see additional swap space using the free command, or in the pseudo file proc mem info. You can also turn off the swap area with the swap off command. Okay, but all those mounts and swaps will be connected to our system only until the reboot. To automatically mount them at the boot time, we must write them to the file systems table. On most Unix-like systems, this is the etc fs tab file. In this text file, we can place some static information about connecting file systems and enabling swapping areas. Each file system is described on a separate line. Fields on each line are separated by tabs or spaces. The first field is the block special file or remote file system to be mounted. The second field describes the mount point for the file system. For swap partition, this field should be specified as none. The third field describes the type of file system. An entry swap denotes a file or partition to be used for swapping. The fourth field describes the mount options associated with the file system. The fifth field is used for those file systems by the dump command to determine which file systems need to be capped. And the sixth field is used by the FSCK program to determine the order in which file system checks are done at reboot time. After putting some entry in the fstab file, you can run the mount command with only one of arguments device or mount point.